Today we will understand what roots mean in the Newton-Raphson method. A root is simply a value of x that makes the function equal to 0. Consider the function f of x equals x minus 3. To find the root, we make the function equal to 0. Adding 3 to both sides gives x equals 3. Now substitute 3 into the function. The function becomes 0. Therefore 3 is a root. A root is where the graph crosses the x-axis. On the x-axis, the y-value is always 0. Since y equals f of x, roots happen when f of x equals 0. Some equations are difficult to solve using algebra. For example, cos x minus x equals 0 cannot easily be solved algebraically. The Newton-Raphson method helps us approximate the root numerically. Now let us understand the method using x squared minus 2. We want to find where x squared minus 2 equals 0. Adding 2 to both sides gives x squared equals 2. Therefore the root is the square root of 2. The square root of 2 is approximately 1.414. Before using Newton-Raphson, we estimate where the root lies. Substitute 1 into the function. 1 squared equals 1. The answer is -1. Now substitute 2 into the function. 2 squared equals 4. The answer is +2. Notice that the function changed from negative to positive. This means the graph crossed the x-axis somewhere between 1 and 2. We now choose 1.5 as the initial approximation because it lies between 1 and 2. Now differentiate the function. This formula helps us improve our approximation. Substitute 1.5 into the function. 1.5 squared equals 2.25. Subtracting gives 0.25. Now substitute 1.5 into the derivative. 2 multiplied by 1.5 gives 3. Substitute everything into the Newton-Raphson formula. 0.25 divided by 3 gives approximately 0.0833. Subtracting gives 1.4167. Notice how the approximation moved closer to the actual root. The Newton-Raphson method is simply a process of guessing and improving.